Hey, topic 13 is on differential equations. I'm going to give you actually two examples so you're ready. They're both kind of similar, but one's a little bit different. And tomorrow's SIG test, if you're looking at it on today, which is February 8th, is really similar to this. So I'm giving you kind of a hint for those of you who take advantage of the videos. Okay, so this is the one that was on the samples. And remember, the big idea here is you have to separate variables. So I have dy dx is equal to 2xy. And we have the initial condition that f of 0 equals 3. So we separate our variables. So multiply by dx, divide by y. We integrate both sides. The antiderivative of 1 over y is ln. The antiderivative of 2x gives me just x squared. And don't forget your plus c. Now, on these problems where you have ln, and particularly where you get f of 0, like this kind of a problem, this is when you want to rewrite it so it's y is equal to ce to whatever is on the right side. Remember the c. The c's are not the same c's. That's important. They're different c's. The constants that we just did are different. We plug in 0 and plug in 3. 0 for x, 3 for y. And we find out that c equals 3. Therefore, our final answer is 3e to the x squared. Pretty typical. This is a pretty basic, easy kind of a problem. So here's one that's a little bit harder. It looks very similar. We have 4xy minus y. Before I could do it, I need to separate variables. I need to get the y's on the left-hand side, the x's on the right. So I'm going to factor out the y as my first step. Now when I move my variables around, I'm going to multiply by dx, divide by y, and it's going to perform pretty much similarly. So now we integrate both sides. You get ln of y is equal to 2x squared minus x plus c. And again, I got f of 0. So it's kind of my clue to plug in, to rewrite it in terms of e. You get ce to the 2x squared minus x. You plug in 0. Again, I'm going to get c equals 3. So my final answer would be 3e to the 2x squared minus x. Now, they're not all going to be with e, but they're pretty common like that, and I wanted to show you this example just in case you see it in the near future.